Question number 21. Discuss the continuity of the following functions. This is a very basic question. Just we use the algebra of continuity. The first question is here. You are given fx equals to sine x plus cos x. Now this is the sum of how many functions? Two functions. So you can write let fx equals to, fx is already there, I'll write hx. hx equals to sine x and g of x equals to cos x are continuous functions. You know, these are the standard trigonometric functions, are continuous functions. And we know that sum of algebra of continuity, sum of continuous functions is a continuous function, and therefore fx equals to sine x plus cos x is continuous. Sine x plus cos x is continuous function, is a continuous function everywhere. Remember, if you draw the graph of sine x minus cos x, it's continuous everywhere. Same way you can answer the two questions. The only difference is here in place of summation, you write the subtraction of continuous functions as a continuous, and therefore sine minus cos is continuous. Third sub question, product of continuous functions is a continuous, and you just write the product is a continuous function. 22 is also very basic question. I'll go to question number 23, which is an important example here. 23, 24 both. So their function is, you are given sine x upon x if x is less than 0. The next here, x plus 1 if x is greater than or equal to 0. Now go back to earlier list of the question from, for example, 11 to 16 we did. So there, if you remember, this is like inequality type question. So we have three cases: less than 0, greater than 0, and equals to 0, turning point. So in the solution, we do like this. You can write in form of cases. Case number 1, for example, x less than 0. Then you have sine x upon x is a continuous function. Why this is a continuous function? It is a continuous function. What's the reason? Reason is as it is a ratio of two continuous function, ratio of two, or you can write division of two continuous functions, sine x and x. Right? This being ratio of two continuous functions, sine x and x, sine x being trig always continuous, x being polynomial. Sine x and cos x are continuous, therefore the ratio is continuous if x is less than 0. Case number 2, what about case number 2? There we write x greater than 0. If x is greater than 0, then you have fx equals to x plus 1 is a polynomial function, you know. I mean straight line function is a polynomial function. And every polynomial function is continuous, therefore fx is a continuous function. Continuous if greater than 0, continuous if less than 0. Now only turning point is left out, that is at x equals to 0, which is very important part, remember. Right. Now we check the continuity at x equals to 0. So let me see that. So now we are checking continuity at x equals to 0. So you can call this as case number 3, x equals to 0. Now this is a turning point. You know question number 11 to 16. You have inequality here, greater, less. So you need to find right and left limit also. So first we find f of 0 here. What is f of 0? Which formula should be used? Second formula, 0 plus 1, which is 1. Okay. You need to find here limit x tends to 0 from right of fx and limit x tends to 0 from left of fx. Now what is meaning of x tends to 0 from right? X is greater than 0. So equals to, which formula should be used is fx. If x is greater than 0, x plus 1. Look at that function. Apply the limit. So 0 plus 1, 1. 0 plus 1, 1. Both are equal. Go to this. X tends to 0 from left means x is less than 0. X is less than 0, then which formula should be used? Your limit x tends to 0, sine x upon x. If x is less than 0, then sine x upon x. You know that this limit is always 1, we already studied. Right? So from 1, here 2, and here 3. From 1, 2 and 3, from 1, 2 and 3, we say that f is continuous at 0. F is continuous at 0, and therefore here we say that function is continuous on R. Continuous on R. I mean it has no point of discontinuity. So you can write therefore if you want to write function has no point of discontinuity. It is continuous everywhere. No point of discontinuity. It has no point of discontinuity. It is continuous everywhere in the domain. In the given domain, it is continuous. Let me go to next example. Question number 24, which is also an important example. This is also an important example. So there, fx is x square into sine 1 upon x if x is not 0 and 0 if x is 0. Right. Now we don't have inequality here. This is not equal to equal to. So we will be having two cases, not equal to and equals to. Earlier you had inequality, so you had three cases. So in the solution here, the case number one, that is x is not equals to 0. Right. Then what about the function here? Function is x square into sine 1 upon x. Right. Now you know that as x square and sine 1 upon x both are continuous. Sine x square being quadratic, it is continuous, and sine being trigonometric function, it's a continuous. As these and this are continuous functions. These are continuous functions. And product of two continuous functions is always continuous. Therefore fx equals to x square into sine 1 upon x is continuous. You can just write if you want, and the product of two continuous functions is always a continuous, and therefore this is a continuous function. So in one case you are through. Now what is the other case? That is case equals to 0, remember. So that is the next case, case number 2, which is x equals to 0. So let me state that here. So x equals to 0 case number 2. So first we find f of 0. Now this is equals to 0. This is given to us. Okay. Now what else we find? Next is this limit x tends to 0. Why we wrote 0 here? Because we are checking continuity at 0 of fx. So here we have this is equals to, we are finding this limit. We check whether this is 0 or not. If it is 0, both are equal and hence it is a continuous function. Which function you are given? X square into sine 1 upon x. Now this is from actual 11th standard limit question. This sine 1 upon x, you know, for every real number x, sine 1 upon x is always between minus 1 and 1. So this is a number between minus 1 and 1. Here you can write, for every x, sine 1 upon x is always between minus 1 and 1. So this is a fixed number between minus 1 and 1. And as x tends to 0, this is 0. So I'll write here 0 into a number between minus 1 and 1. A number from minus 1 to 1. Right? What's the range of sine function? There are some other ways also to prove this, but I think this is easier, so I'm doing this. If you apply the limit here, it becomes, remember, 1 upon infinity, which is 1 upon 0, which is infinity, so undefined. But you know that for every real number x, sine 1 upon x is always a number between minus 1 and 1, whatever that number, that's not important. But as x tends to 0, this goes to 0. So you have 0 into something which is 0. So this is 2. So from 1 and 2, what's the conclusion? From 1 and 2, function is continuous at 0. And in case number 1, it was also continuous. So therefore you can say that here function is, you can say that continuous on R, continuous on all real numbers. The question was, is this continuous function? The answer is yes, this is a continuous function. It has no point of discontinuity. Okay, 25, it's just a copy of this 2 simple question. Just refer it, you can do it. You will be having 2 cases. Not equals to 0, then it will be continuous. Equals to 0, you can do it in 2 cases like the previous question, but it is very simple, so not a big task for you. Try it, you can do it. Okay, now we go to question number 16 to let me see, 38th number. All are again important questions, but not difficult to remember. So I'll go to question number 26 now. Question number 26 to 29. Find k given that the function is continuous at a given point. So you already given that the function is continuous. What you want to do? You want to find the value of unknown k here. Okay. So let's use that here. Given that f is continuous. This is given continuous at pi by 2. This is given in the question itself. You are not going to check the continuity, remember. You are already given that it is continuous at pi by 2. Therefore, according to definition, you have this limit x tends to pi by 2, fx must be same as f of pi by 2. This is definition, remember. You recall the definition of continuity. What is the definition of continuity? Limit x tends to c, f of x equals to f of c. This is the definition of continuity. Function is continuous at c means we have this. Instead of c, we have pi by 2. Why we are not use right left here? Because we don't have inequality. If you have something like this, then you need to use right left limit here directly. Now what is the f of pi by 2? If x is pi by 2, then the value of the function is 3. So this is 3. So question is just to get the limit. So it's ultimately question to limit only. So we find limit k into cos x upon pi minus 2x. Now you know from 11th standard constant you can take outside, so k will come out. You know this, k will come out. Limit x tends to pi by 2. Here you can take 2 common, so this is pi by 2 minus x. Why I'm doing this? You know, if you have any limit question involving trigonometric function, then either you must have sin x upon x or tan x upon x. So I'll write in form of sine. You know cos x, you can write pi by 2 minus x equals to 3. Now look at to this portion. You know that here sin x upon x, limit x tends to 0 equals to 1. Remember here your theta is pi by 2 minus x, and as x tends to pi by 2, what about x minus pi by 2 tends to 0? So this is like 0, this is like 0. So k by 2 into that selected portion is 1 equals to 3. So therefore k equals to 6. I hope this portion is clear to you. In every limit question involving trigonometric function, you must have either sin x upon x or tan x upon x. So what I did, I have reduced cos in form of sine, pi by 2 minus x. Now I need the same angle here, so taking 2 common, so this is pi by 2 minus x, and therefore k is 6. Okay, now here next question, if you see question number 27, which is too simple, I'll not do that. So I'll go to question number, let me go to question number 28. Yeah, 28 number. What about the function here? There kx plus 1, x is less than or equal to pi, cosine x where x is greater than pi. Now here remember in this question, continuity you are given. So what is given? Given that f is continuous at pi. This is given in the question itself. You are not going to check the continuity. Now you see in the definition you have inequality. So therefore we need to use right left limit, remember. So f of pi, that is equals to limit x tends to pi from left of fx equals to limit x tends to pi from right of fx. Why I have used the right and left limit here? Because we have inequality. Just recall the definition. In the previous question here, I have used just this much because I don't have inequality. Inequality means like this, you know. You have just not equal to, remember. That difference you must realize. Okay. Now very simple. What's the meaning of x tends to pi by 2 from right? X is greater than pi. If x is greater than pi, then this function. So I'll write here this cos x. What's the meaning of x tends to pi from left? X is less than pi here. X is more than pi here. Remember, more than pi, then this. Less than pi, then this function. Limit x tends to pi from left of kx plus 1. What is f of pi from here? So put pi here. So k pi plus 1. K pi plus 1. Putting pi instead of x. Now apply the limit. Now plus minus sign is not important. Just put pi here. You know cos pi is minus 1. Apply the limit here. K pi plus 1. That is same as this. What is pi? That's minus 1. Plus 1. So therefore k equals to, if I take this one over here, minus 2 by pi. This is your answer, remember. So value of k is this here. 29th, if I do in a short way, for example, here function is continuous at 5. This is given to you. Now if you look at a question, you have inequality. So we need to use right left limit. Limit x tends to 5 from right of fx equals to limit x tends to 5 from left of fx equals to f of 5. You can write in detail why this, as I explained. So here this means x is more than 5. If x is more than 5, then you have which function here? Limit x tends to 5. Look at that function. X is greater than 5. Greater than 5, then 3x minus 5. X is less than 5 here. If x is less than 5, then which function? Less than 5, then you have kx plus 1. You can write f of 5 also, but this 2 gives you answer. Now apply the limit. So if I apply the limit here, 5 3 is 15 minus 5 here. Apply the limit here, remember. So you have 5k plus 1. Put x equals to 5, so 5k plus 1. So this is 10. If you take this one on the other side, this would be 9 equals to 5k. So therefore here finally we are getting k equals to 9 by 5. This is the value of k for which function is continuous. So next 30th number, which is again a very important example. You are asked to find a and b. So this is an important example. We want a and b. You are given that it is a continuous. Now here where it is continuous, that's not given to us. So what usually in such questions we do, we use the continuity at turning point. So we use one at 2 and the other one is at 10. These are the two turning points. So in the solution, what is asked? You are asked to find a and b. We find small a and small b. That's the question. We find a and b. How many unknowns you want to find? 2 unknowns, a and b. So we need to use continuity twice, like earlier questions. In all earlier questions, you were finding k. That was at a single point. So we use continuity at 2 first. So function is continuous at 2. You are given that it is continuous everywhere, but we are using only turning points. Only turning points are important, remember. Now what's the meaning of this function is continuous at 2? Limit x tends to 2 from right. Now you know very well this. Equals to limit x tends to 2 from left of f equals to f of 2. You know this now. Now what is the meaning of x tends to 2 from right? X is greater than 2. If x is greater than 2, then this formula. So I'll use this here. Limit x tends to 2 from right. X is greater than 2. X is greater than 2, then ax plus b. Limit x tends to 2 from left. That means x is less than 2. X is less than 2, then your constant 5. No need to do this. If you find 2, again you will get these only. Now apply the limit. So instead of x, I am going to write 2 here. So 2a plus b equals to constant 5. We call this as equation number 1. If you remember, we had one of the question in the earlier exercises, find the relation between a and b. This is like question number, if you go back to earlier list, it's a question number 17. It was up to this only, remember. You had asked to find the relation between a and b in 17 number. Now, next, again we use continuity. Again, f is continuous. At which place? At the other turning point. Which one is the other turning point there? The other turning point is nothing but which one? 10. So we use this. So at 10. And therefore, limit x tends to 10 from right of fx equals to limit x tends to 10 of left of fx equals to f of 10. Okay, so now just put the value. What's the meaning of this? X is greater than 10. What's the meaning of this? X is less than 10. Use the appropriate function. So limit x tends to 10 from right. X is greater than 10. X greater than 10, then this is a constant 21. X less than 10, then ax plus b here. So limit x tends to 10 from left, ax plus b. If you find f of 10, here it will be 21, so you'll get the same, so no need to write that. If you want, you can write it, but that's not important. Now this is 21, apply the limit, so this is nothing but the 10 a plus b. So this is another equation about a and b. And then just solving 1 and 2. You solve this, solving 1 and 2. You solve these two equations, so look at the values. So from 1 and 2 here, a is 2, just use elimination for these two. A is 2 and b is 1. Just do this much. So get the values of a and b. So question number next 31 to 34 all are based on the algebra of continuity. Like if I see 31, their function is given by cos of x square. Now as I explained earlier, if you remember, this is a composition of two continuous functions. Which two? Cos x and the other one is x squared. So I'll take like this, let g of x equals to cos x and h of x equals to x squared. Now these are continuous functions. These are continuous functions. Why these are the continuous functions? Because both are standard functions. Trigonometric functions is continuous, x square being polynomial is continuous, and therefore these are the continuous. Therefore their composite function, if I write g-o, this is the inner function, g-o h at x, which is g of h of x, which is nothing but the cos of x square, is a continuous function. This much only you have to write. Continuous function. Such questions are not important for examination point of view, but you should know at least what we mean by algebra of continuity. 32, if I go to 32, there fx equals to modulus of cos x. Now this is also composition of two continuous functions. Which two functions? You can take gx as cos x and h of x as modulus x. Again, both are continuous functions. So write in your language, both are continuous functions. Trigonometric function is always continuous, modulus is always continuous. Therefore, their composite function or composition, their composite function, if I write g, this is inner function. So here I need to write hog at x, which is h of gx. So here gx is cosine x. So modulus of cosine x is a continuous function. Is a continuous function, remember. Is a continuous function. Okay. Now, same way you can go to 33 also. What about 33? Question number 33, which is sine of modulus x. Now this is also composition of which two functions? One is sine x and the other one is which one? Modulus x. This is a continuous function, this is also a continuous function, and their composition, this is the inner function, so their composition sine of modulus x is a continuous function, remember, is a continuous function, right? So here this says that composition of two continuous functions is a continuous function. So in all these three questions, everywhere we have used algebra of continuity. That is, if two functions are continuous, their summation, their product, their division, and their composition is always a continuous function. If I go to last question now, let me see the last question. So here for this function, question is find This is a question. We find all points of discontinuity. Points of discontinuity. This is a question. Find all points of discontinuity. By just observation, you can see that this being modulus, so we can write here modulus x is a continuous function everywhere. Is a continuous function. Standard modulus function. You know that this is a graph. It's continuous everywhere. And modulus of x plus 1. This is actually composition of x plus 1 and modulus is a composition of two continuous functions x plus 1 and x, hence it is continuous function. This also you know very well. It's a composition of x plus 1 and modulus is a composition of two continuous functions x plus 1 and x, hence it is continuous function. You know the graph of this function. There is a graph where this becomes 0, here minus 1. So this graph, just for your reference, I'm showing you this is a graph of this function, you know, from 11th standard. So this is a continuous function. This is a continuous function. And subtraction of two continuous functions is always continuous. Also, subtraction of two continuous functions is continuous. And therefore, modulus x minus modulus x plus 1, which is fx, is a continuous function everywhere. Is a continuous function. It has no point of discontinuity. Therefore, you can say that here function f has no point of discontinuity. It's continuous everywhere. It has no point of discontinuity, remember. So this way we can give the proof using the algebra of continuity, remember.